I am Annalisa and today's video is all about the resolving power of telescope. At the end of this video, the student should be able to explain the concept of resolving power, calculate problems about the resolving power. So first, what is meant by resolving power? Resolving power is the ability of the devices to distinguish two objects at a distance and produce clear image. Let's draw it. Assuming this is the lens of the telescope and let it be the diameter from here to here. These two lines are going to the two objects at far distance. Let it be the theta minimum, and it is for us to see the distinct of separate objects. So let's name this line the observing wavelength or represented by the sign lambda. To get the theta, we need to get the angle here between the red and the yellow stars. So in this drawing, you can still see the two stars separately, right? If the theta is greater than the arc minute, we can distinguish the red and the yellow. And as you can see here, in another drawing, the stars cannot be distinguished, right? If the theta is less than the arc minute, we cannot distinguish the stars. From this drawing, we can say that theta minimum or minimum theta is equal to the lambda over the d or the diameter. So for your information, 1 radian is equal to 180 over pi, or it is equivalent to 57.30. 1 degree is equal to 60 minutes of arc, and 1 minute is equal to 60 seconds of arc. And now, I will discuss the resolving power of telescope. It simply means the ability of telescope to display two images like stars or planet separately. I have here two stars, the red and the yellow, okay? As we can see, we can distinguish them clearly as two stars. So we can say that these are resolved stars, okay? The next is the stars just resolved. In this situation, we can still say that there are two stars. However, it is not as separate compared to the first image I've shown you a while ago. Do you see the difference? Now, let's see the image of stars without resolving power. Imagine these are two stars in the sky, okay? Without the resolving power or the use of telescope, this will show. You cannot even distinguish if these are two stars, right? It's because these stars are unresolved. Now, I will draw the angular radius of Eridis. So, this is the point source, and this is the image which has so many rings, as you can see. These rings are called the Eridis. Let's drop these Eridis. So this small here are the smaller or other rings in this image. And this big curve here is the Eridis that represent the big ring in here. Now, I will show you the graph of the stars I've shown you before. So this is the dis or the Eridis of the first image I've shown you. And this is this next graph is the graph of the second image. And this last, as you can see, this graph is so close to each other, and the form image, as you remember a while ago, is the stars that are blurred, and we cannot even distinguish if these are two stars or just one. Let's try to answer some sample problem. Number 1. What is the resolving power of a 25 cm or 10-inch telescope at a wavelength of 550 nanometer in the middle of the visual band? So we will do the step-by-step solution. 1. Given the formula, resolving power is equal to 1.22 lambda over d. Here, lambda is the wavelength and d is the diameter of the telescope. We need to convert first the unit of diameter from centimeter to meter. This is how we will convert the centimeter to meter. 25 centimeter multiplied by 1 meter over 100 centimeter. We just need to cancel the centimeter, both centimeter, so that we will get 0.25 meter. Next, convert the units of lambda from nanometer to meter. So the lambda given is 550 nanometer. We will multiply it to 10 raised to negative 9 meter over 1 nanometer because 1 nanometer is equivalent to 10 raised to negative 9 meter. So again, we just need to cancel the same units and multiply 50 and 10 raised to negative 9 meter. Just need to substitute 0.25 for the diameter or for the d. 1.22 multiplied by 550 times 10 raised to negative 9 meter over 0.25 meter is equals to 2.684 times 10 raised to negative 6 meter. Again, we will still need to multiply it to arc seconds. So, 2.684 times 10 raised to negative 6 meter multiplied by 3,600 arc seconds. The final answer is 0.0097 arc seconds. 0.6624 times 10 raised to negative 3. So, how did I get the 0.0097 arc seconds? I just move 3 times to the left because exponent is negative 3. It means we need to move to the left and added 2 0. And that's it. Let's try another problem. Calculate the resolving power of a telescope when light of wavelength 540 mm is used. Diameter of objective lens is 6 cm. Again, the first step we need to do is to write the given. The lambda or the wavelength is equal to 540 mm and it is not yet in the meter, so we need to convert it in meter. 540 mm equals 540 times 10 raised to negative 9 meter. This is already converted. As you can see, the given is in 6 cm. Resolving power is equal to 6 times 10 raised to negative 2 meter because that is the diameter over or divide 1.22 times 540 times 10 raised to negative 9 meter. You can try it on your calculator too if you have. And the answer is 9.1 times 10 raised to negative 4. Again, the answer from the calculator is 91,074.68124. That's all for today's video. I hope you understand our lesson for today. Again, I am Annalisa and thank you for watching.